Okay, for the next example, tastes as good as a real thing. The maker of a Diet Cola claims that its taste is indistinguishable from the full calorie version. Yeah, right. To investigate, students prepared a small sample of each type of soda in identical cups. Then she had volunteers taste each cola in a random order and had them try to identify which was the diet and which was the regular. Overall, 23 of the 30 subjects made the correct identification. If we assume that the volunteers couldn't tell the difference, then each one was guessing with a 1/2 chance of being correct. So basically, if you're drinking these two sodas and you don't know which one's which, the probability that you guess the diet one right by random chance would be 50-50. So you got a 50-50 chance if you don't know. So let x equal the number of volunteers who correctly guess under the assumption that they can't tell the difference. Find the mean and standard deviation. So I think this is binomial. Bins, either they guess it right or they don't. Independent, if one person guesses it right, it doesn't influence the other person's. Set number of trials. I have 30 people that are in the experiment or study. And the probability of success is the same because I'm assuming they don't know, so it's 1/2. And we're going to record the number of people that get it right, the number of successes. So this is definitely a binomial model. So again, this is 3 points right here on a test. If you don't put those 3 things down with labels, you're going to lose points. Find the mean and standard deviation. So look at your formula sheet. The mean is simply n times p, which is 30 times 0.5, which is 15. Of course, if people don't know which one's which, I would expect half of them to guess it right by random chance. Standard deviation, square root of npq, which is the square root of 30 times 0.5. The probability of a failure is also 0.5 because it's 50-50. So type that into your calculator. 30 times 30 times 0.5 times 0.5. 2.739. 2.739 people. So I'd expect 15 people to guess it right, and I would expect the number of people to be spread out about 2.7 people from that. So I know what this is probably leading us to is 23 out of 30 unlikely under this assumption. You can kind of look at that and kind of evaluate that. 23 is like, what is that, like 3 standard deviations above the mean? That's kind of unlikely. Interpret the above results in context. So I wrote these for you so we don't have to write it down, which is nice. If this experiment were repeated many times and the volunteers were randomly guessing, the average number of correct guesses would be about 15. Nice. Also, the number of correct guesses would typically vary by about 2.74 people from the mean. I don't feel like I should have people here, but I don't, whatever. I don't know. I guess it's a count, so whatever. Of the 30 volunteers, 23 made the correct identifications. Does this give convincing evidence that the volunteers can taste the difference between diet and regular colas? Justify. So I want to know, what is the probability? So when people guess, 0 could get it right, 1 could get it right, 15 could get it right, 22, 23, 24, or 30 could get it right. I mean, those are all the outcomes. I want to know, assuming that it was really 50-50 and people couldn't tell the difference, I want to know how likely is it for 23 or more people to get it right? Because that's what happened. We had 23 people get it right. So I want to sum these up. What is the probability that x is greater than or equal to 23 given the assumption that people were guessing? People were guessing and couldn't tell which one is which. Well, this is a binomial CDF. N equals 30, P equals 0.5, lower bound equals 23, upper bound equals 30. So statistics, distributions, go down to our binomial CDF. Boom. 30. 0.5 chance of success. I want to go from 23 to 30. 0026. 0.0026. So this is really, really small. What this tells us is, if people were really guessing, the probability that you would get 23 people or more to guess right by random chance alone is less than 1%. 0.0026 is small. So I want to write like a whole paragraph, and I didn't leave enough room. So I know I'm sorry I'm not going to write it down. I know some of you probably would like that, but I'm just going to say it. Because this value is very, very small, the probability that we got 23 people or more due to random chance is less than 1%. Because that's small, our assumption is probably false, and the reason we got 23 or more people was because people really can tell the difference between the diet beverage and the regular beverage. So this is convincing evidence that people can tell the difference between the two brands. And the company's claim that it's indistinguishable, I would say is false. I say people can tell. At least some people can tell. All right. 7 minutes. I'm going to the next video.